Hello everyone. I hope I'm audible and you are in good health. And we are happy to welcome you to this webinar on the roles of remote operations in the autonomous driving. And we are also happy to have the prestigious expert from the George Mason University, USA, Mr. Marek Vanjura is with us today for this webinar. I welcome you, sir. Let me introduce you. Mr. Marek is a postdoctoral research fellow at George Mason University, USA. For more than 5 years, he has been active in the field of autonomous vehicles and unmanned technology. Prior to this, he has worked as a pioneering director of autonomous vehicle research with experience building and leading a cross-functional department and partially remote disciplinary team of 7 researchers for autonomous driving. He was also the member on Committee of Automated, Cooperative and ITS System at Ministry of Transport, Czech Republic, and he is also a member of Automated Driving Group at European Transport Safety Council. I welcome you, Mr. Marek, and request you to take over the further session.
Thank you, Amos, so much. Hello, everybody. Good afternoon. It's a pleasure to be here. First, let me please share screen with you. Okay. Could you let me know if you can see the screen? Can anybody see the slides?
No, it is not yet visible.
Not yet visible? Okay. Let me try that one more time.
Mr. Marek, I would request you if you can turn on the camera as well for the participants.
Yes, let me do that. Hello? Still no slides, or can you see them now?
Yeah, I can see you perfectly.
Okay, good. So thank you so much. And my today's talk is called The Role of Remote Operation in Autonomous Driving. In the field of autonomous driving, there always has been this discussion and talks about different modes of driving. And besides autonomous driving, we might hear about remote driving, and these sort of modes in opposition to manual driving. Or you can even hear some discussions about that manual, remote, and autonomous driving are sort of discrete tasks that don't really overlap, and they don't really create a continuum. What I will try to show you today is that they actually do create continuum, and they are very much complementary to each other. So let me start with explaining what these different modes of driving mean. Manual driving is something that many people are already familiar with.
Hi, Mr. Marek. Actually, your screen is not visible.
Okay. Is it possible to share the screen on your side, the presentation that I sent you? It might be easier if there's some issue on my side.
Yeah, just a minute.
Okay. Oh, okay. Thank you for the information. Good evening. Okay, perfect. Thank you so much for sharing the slides. It seems like, yeah, they're working. Perfect. So let me continue. We can move to the next slide. Everybody seems like seeing these slides. Yes, great. Thank you. So yeah, there are three different modes of driving: manual, remote, and autonomous driving. And my today's job is to show you that all these three modes are somehow complementary to each other, and they make sense within the scope of autonomous driving at different times, and they sort of create this continuum. So manual driving is something that many people are very familiar with, and which means that vehicle is driven by a person, a human, inside of the vehicle, using steering wheel, pedals, sometimes even clutch, gear shifting, and so on. So that's one mode. The other mode is called remote driving, and in this case, the vehicle is driven by a human who is outside of the vehicle. There is some remote wireless connection between the vehicle and the operator, the driver, who controls this vehicle. So it seems or feels like it's one step towards autonomous driving, because the vehicle might be empty, and so we can call it driverless, in sense of the vehicle doesn't really have anybody who's controlling the vehicle within the vehicle. But it's not really fully there, because there is still some person sitting behind the steering wheel or pedals somewhere outside of the vehicle. And finally, there is autonomous driving, which means that vehicle is driven by an onboard computer. In this case, there is no direct human intervention or direct human input driving the vehicle. So that's like the steps from fully manual driving to fully autonomous driving. Let's give me an example how this can be manifested within the actual autonomous driving environment. Could you please move to the next slide? The example that I'm trying to give you is the example of robotaxi fleet. Nowadays, there are several robotaxi fleets around the world, mostly in the USA and in China. Let's take as an example the robotaxi fleet in San Francisco by the company called Cruise. And in this case, they have a fleet of autonomous vehicles without anybody on board, which is yeah, Ranjit, do you have a question, or you raised a hand?
No, we can continue. We can take question at later after this session.
Okay, sounds good. And so they have this fleet of vehicles, and I can see some comment that they can't see slides. Oh, one page back, but seems like some people can't really see the slides, even if you're sharing it. Is it true for everybody that the slides are not visible?
Yeah, they are visible. There may be some network connectivity issue, because they might.
Oh, okay. So some people seem to see them. Okay, good. So yeah, the example with robotaxi fleet is that most of the time their vehicles are moving a lot around the city independently. They drive on their own, and there is nobody really actually driving them or controlling them. But sometimes there are these situations when these vehicles might encounter something unexpected, like it might be a road work, it might be some obstacle on the road, or some other situation that the autonomous driving system cannot really handle on their own. In this case, there is they send some request to a remote control station, or let's say some control tower, which oversees these operations, and the vehicle informs that it cannot handle the situation and asks for some sort of support. And in this case, this remote dispatcher, this remote operator, helps the vehicle resolve this situation. And once it's done, the vehicle can continue again autonomously. But also there might be situations when actual manual driving is necessary. For example, when the vehicle returns back to its depot, someone might actually sit in the car and drive it to parking location or to charging station. Or when they deliver the vehicle, on a trailer from a manufacturer, they might actually need to drive the vehicle manually from that truck to the parking garage and so on. So all these three modes of driving are in some situation, in some time needed for even, fleet of autonomous vehicles. And as David Mindell, the researcher and MIT professor at MIT said, is that autonomy is a human action removed in time. What it means is that even when we talk about autonomous vehicles, autonomous systems, autonomous machines, they are executing something that human programmer, human designer put in them. So there is really, he calls that as a myth of autonomy, myth of, that when something's autonomous, it's fully independent on humans. That's not actually true. It means that it's executing some commands, some guidance given or received from a human operator or some human programmer. So what I'm trying to show is that it's not really manual driving versus remote driving versus autonomous driving. There is no opposition in between these modes. It's actually manual plus remote plus autonomous driving that create this sort of one system and is needed for safe operations of autonomous vehicles. Can we move to the next slide? So it probably shouldn't be a surprise that there are many different taxonomies or classifications of teleoperation. And one of the most standard ones is this one where we have three different modes. The first mode is remote driving, which means that the remote driver who sits somewhere outside of the vehicle is directly controlling the vehicle using standard, automotive control devices, such as steering wheel, such as pedals, and so on. And for this purpose, they are controlling the vehicle via some wireless network. So this is like the direct driving. Then we have something called remote assistance. In this case, the remote operator assists usually the passenger in the vehicle. So we might call this functionality as some sort of rider support or even call center, and all this and something like this in this area. So it means that in this case, the remote operator is not really guiding the vehicle or helping the vehicle itself. This operator is helping usually the rider inside of the vehicle, for example, if they need to pull over or if they need to ask for some assistance, some help, and so on. So this is something called remote assistance. Then we have the third version or third class, and this is called remote management. In this case, this remote operator is again interfacing the vehicle, and in this case, it's helping to resolve some issue through guiding it, but not using some direct control like actually driving it, but using some other points, other ways, such as using commands like turn to the left, turn to the right, execute, U-turn, and so on, or giving the vehicle waypoints, like drawing the trajectory that the vehicle should drive, for example, to avoid an obstacle. And the autonomous driving system actually executes this command, these instructions by itself. So it's some sort of like offline, not in real time assistance. Or another kind of remote management might be object classification for autonomous systems. In this case, the vehicle might encounter some vehicle that seems like is waiting at traffic lights, but in fact it's double parked. It's just parked in a traveling lane, and it won't move because there is no driver inside. They just park there. In this case, the autonomous car can ask the remote operator about it. The remote operator, because this person has the human intuition and can tell, like, okay, this vehicle is parked there, so they won't move anytime soon. And they will remotely classify this vehicle not as a vehicle but as an obstacle. And the vehicle knows that if it's obstacle, it can drive around it. So these are kinds of remote intervention or classifications of teleoperation that we can see. But also, it's not that surprising that there are many other ones. And also, basically every company working in this domain has their own sort of nomenclature or their own name for these functions or the functions that their vehicle implements. So it creates a little bit of mess. But if we move to the next slide, there is another classification issued by the company called DriveView Auto, and they have very in-depth detail and very, I would say, smart classification of teleoperation. In this case, they basically distinguish between two modes. It's either remote driving or teleassist. In this case, remote driving can be direct driving, which means the vehicle is driven directly by some operator, or they can have some low-level or high-level control where they control different aspects of the dynamic driving task. And then we have something called what they call teleassist, and this is more like remote management. And as you can see, it can be guidance through waypoints. It can be advising, like this, as I said in the example of the object classification. And it can be just supervising when they just oversee, the fleet and or the vehicle on some particular vehicle and might stop it when needed. Can we move to the next slide, please? Yes. So once we know what different aspects or different kinds of teleoperation there might be, it's useful to talk about what are the actual use cases for teleoperation. And actually, there are many. One of them that I already talked about is a use case of teleoperation as a backup system, as some additional safety layer to autonomous driving. In this case, when the autonomous vehicle encounters some situation that it cannot handle, it asks for help, and teleoperation works as a backup system, how to maintain some functionality of this fleet through providing remote assistance and dealing with unexpected obstacles or unexpected situations that the autonomous driving system cannot really handle. So that's one use case. And this one is relatively common. Many operators of autonomous vehicles use this system, and it seems like it's some standard use of teleoperation. But we have also other ones. For example, use case of delivery robots. In this case, some delivery robots are these small, relatively small machines which can move on sidewalks among pedestrians, and they deliver goods or orders from restaurants and so on. And some of these delivery robots, some of them are autonomous, some of them are remotely operated. And in this case, teleoperation is used for controlling these tiny machines on sidewalks, and moving them from restaurants to customers and so on. Then we have another use case, which is utility vehicles. In this case, teleoperation is used for controlling vehicles such as forklifts or heavy vehicles in mines and other vehicles in the logistics sector. In this case, teleoperation is employed or deployed in such a situation where most of these vehicles are not really on public roads, but they are working in some sort of separated environment. It can be a warehouse. It can be some dock near a harbor. It can be some logistics center and so on. So requirements for these teleoperation solutions are, I would say, lower than when we are talking about deploying robotaxi fleet on public roads. So these are, we might call them like entry points, these utility vehicles or maybe delivery robots. And then we have something that is we might call like car deliveries, remote car deliveries. And in this case, teleoperation is used to deliver cars to customers of car rental companies or car sharing companies, which means that there's a customer who wants to rent a car, but in this case, this person doesn't have to go to some office to pick up the car and then drive from there, but basically they book it online through some mobile app, and the vehicle is delivered to them empty using remote control. So this is very interesting use case. It's currently being promoted by several companies in the US and in Europe, and we don't know yet if this use case will be viable, if it will be economically meaningful, but it seems like plenty of these companies really believe in that. However, it's quite difficult to assess really if it will take off, in some larger scale, because currently these deployments are relatively small and they have very limited number of users and they are restricted geographically. So it's hard to tell, if this will work. And also with the expansion or let's say advancement of autonomous driving, this might turn out not to be really as functional as it seems right now, but we shall see. So these are basically the main 4 use cases for teleoperation. There might be some other ones, but I feel they can be subsumed under these categories. And as I mentioned a little bit already, is that these use cases are different in terms of, or differ in terms of how easy they are. And this has something to do with limitations of current technology of teleoperation. So if we can move to the next slide, then we will talk a little bit more about what are these current limits of teleoperation. And in this category, we can basically distinguish them to 2 categories. The first one is limits that are related to technology itself. So this might be, we can also think about them as probably solvable in the near or longer time period, because if something is related to technology, it usually can be resolved over time. And then we have issues or limits which are related to human factors. In this case, it's mostly on the side of the remote control station, and this relates to the actual human driving or controlling the vehicle remotely. So I will dive a little bit deeper into each of these groups. On the next slide, the limits related to technology are many, and one of the most important ones are these 3: latency, network availability and its quality, and video quality. Latency basically means that is another name for a delay. Latency in terms of teleoperation means what's the time delay between when the remote operator makes something, for example, presses the brake pedal, and when they see the action on their screen. So in this case, when they start, for the first time, they will see the vehicle braking. And of course, you need this loop to be delayed as little as possible. So you need, or you have to have as low latency as possible. What this means is basically some current wireless networks are able to provide you with delay or with latency around, let's say, 30 milliseconds, which almost feels like real time. This latency is almost unnoticeable, and it allows you for the safest sort of remote driving. But this might be in many cases quite far away in the future, because most of the wireless networks currently allow you to have latency around, let's say, 100 or 200 milliseconds, which is still fine, or it's still, the vehicle is still drivable, but with some limitations. And these limitations usually mean that you can drive a vehicle usually at low speeds, let's say 20, 25, 30 kilometers per hour. But anything above this threshold might not be really safe because of this delay between, when you send a signal and when you see the actual reaction of the vehicle to it. So currently 100 to 200 milliseconds is something that most of these solutions use. And if you have latency above, let's say, 300 milliseconds, it might not be really safe for deploying in terms of direct remote driving. It might still be fine for this teleassist, for advising the vehicle using waypoints, using object classification, and so on. So because this command is then executed by the autonomous driving system itself, and it's not really that relevant if if it arrives within 1 millisecond on 1 second. This difference is basically not as important because the vehicle will drive itself. So the latency is the biggest issue, and currently there are ongoing works how to make this as little as possible. Another issue is network availability and the quality of this network. This means, wireless networks are not really accessible everywhere, so it limits where you can really use this cell operation. Currently, these vehicles usually rely on 4G networks, 5G networks, and some, if there is some private Wi-Fi network, it can use that. So these developers try to implement all these available networks, and different providers use independent physical networks of these wireless towers, cell towers, because of redundancy. But really, it's not accessible everywhere, and the quality might be variable due to many reasons. The weather can influence it, but more importantly, for example, higher demand in that area might cause decrease in quality of the network. For example, when there is some sport event, suddenly there are thousands and thousands of people using their mobile phones. They want to share videos, they want to call, they want to send messages, and suddenly these networks might be overloaded. And if some system, such as autonomous driving system relying on teleoperation, starts to use this, it might be very much delayed. The latency might increase. They might not even be able to connect. And such a safety critical system, like driving a vehicle, if it relies on something that's not really that reliable, it causes a big problem. So the network availability and quality itself is a very important part of the issue that current teleoperation is facing. And finally, there are some issues with video quality. Of course, if you're driving the vehicle remotely, you want to have the video image, as great as possible. Sometimes it's not possible through, these issues with the network. So you might get the video feed from the vehicle, from cameras on the vehicle, might be compressed too much. So you're not really getting very clear picture, very clear video. Another factor might be that the cameras themselves might not be of the best quality, so they provide some distortion. Their field of view might not be, what you need, and also another factor is that cameras are not really matching the quality of human eyes yet, which means, for example, the dynamic range is not that high. And for example, when this vehicle is entering or leaving the tunnel, there is this quick switch between darkness and light. And usually many cameras, or most cameras, have really big issues with this. So if this remotely driven vehicle is leaving the tunnel and the light is turning from dark to light, very bright sky, suddenly the camera might be blinded, and therefore the remote driver might be blinded, and they don't really see what's happening. So this is another factor that can be probably resolved in the future with the advancement of cameras, but currently it causes some issues. And related to this, even like the way of these cameras are placed on the vehicle might cause some problem. Usually what you want to do is to have these cameras on the vehicle arranged in a way that they see all 360 degrees around the vehicle. But because of the limitations of human brain, human visual system, and the way that how you present these video feeds, you might not be able to really see all 360 degrees. So, all around the car because of the limitation of human brain, human vision processing, and so on. So this is also important to sort of resolve how to present this information and in what way in order to provide enough information for this remote driver. Now on the next slide, I will tell you a little bit more about this functionality of human perception system and how situational awareness works. So factors relevant for or limits of teleoperation related to human factors might be again categorized into different groups. I would categorize them like presented on a slide. The first one is the first limitation, which is quite significant, is that because the person is not really sitting in a vehicle, there is this absence of physical cues or sensory information that you would usually get when you're sitting in a car, but you're not really getting because you are not in the car. This means lack of feedback on like acceleration, deceleration, some G-forces when you're making a turn. You don't have this feeling of incline, so you don't really feel when the vehicle is going up, some steep hill or going down. All these things are missing. Also, you usually don't hear sounds in this remote station, which sound is also quite important element for human driver in a vehicle. So it might be sound of your own vehicle, it might be sound of other vehicles, of other road users, and so on. So all these elements are partially or fully missing, and it makes the driving remotely more difficult. So there are also some works on how to provide this remote driver with all these, or at least some of these cues or sensory inputs that might be helpful for feeling more immersed and feeling more, as being inside of the vehicle, even though this driver is remote. So that's one of the factors, human factors limits. The other one, which also relates to what I said in the technological limits, is decrease in situational awareness. Situational awareness is something that describes how the human is aware of the surroundings and of all the happenings around the vehicle in this case. So situational awareness is obviously decreased because of the absence of those cues, and also because there's basically just one vantage point that the remote driver has, and this vantage point is provided through those cameras, how they are placed. So, if you're driving a car, you can tilt your head, you can move your body to get, better perspective, to get, other view. This is something that you can't really get when you are driving a vehicle remotely. So naturally, situational awareness is decreased. And also, the cameras, they have limited field of view, they have limited, which limits like depth perception. And all these things together, they cause this remote driver to have lower situational awareness. And there are, of course, ways how to overcome this partially. For example, you can use some sort of augmented reality, extended reality. You can use some visualizations that are sort of synthetic, but provide some information that's missing from those video feeds. And in this way, you can increase the situational awareness of these remote drivers. And another thing that I would like to talk about, and it's something that I'm really interested in recently in my research, is that there are some specific experience subjectivities. What I mean by this is, for example, something that is called as PlayStation mentality. And this is usually mentioned in a context of military drone pilots, that, because the interface that they control is remotely piloted aircraft is so similar to computer games that they might get this PlayStation mentality, and they might treat what they see on a screen more as a video game than a reality, which in the end decreases maybe their sensitivity towards what's happening there, and they might become probably more violent. So in terms of remote driving, can we also, no, I wouldn't say also, but can we notice something like PlayStation mentality in drivers? And it seems like, the more experienced remote driver, the more likely is that they will become confident enough to not fully realize the consequences of remote driving and what might happen if they crash the vehicle or if they hit something. So this is research on what are the elements that influence maybe this emergence of some sort of, let's say, PlayStation mentality, or mentality that allows these human operators to treat the actual task as less real as it would be if they were sitting in the vehicle. Another thing in this might be how the identity or the task is perceived by the human operator when it's done remotely. What I mean by this is I had this personal experience with remotely driven delivery robot. When I ordered something, I set a pickup location where the robot should go, and as the robot was approaching me, I kind of moved away from this pickup location, and I was watching the robot from different place. But because it wasn't autonomous, it was driven by some remote operator, he noticed me through the cameras and assumed that I'm the customer. And instead of going to that pickup location, he turned the robot and went directly towards me, which is something that you wouldn't expect from autonomous driving, but it's something that's quite human. Like, he probably assumed, yeah, this will be more convenient. He doesn't have to go to that, original pickup location. I will save him some steps. I will, deliver it directly to him. But because I sort of ignored that robot when it came to me, and insisted on going it to the original location, after a few moments, the remote driver basically turned the robot and went back to the original pickup location. So that's something, there is some sort of assuming behind this remote driving when there are humans behind it. So understanding, what are their subjectivities, what are their understandings of the system, and their intuitions and assumptions might be also important to understand, what are these human factors limits, because sometimes they say that when you have autonomous driving vehicle, you always know what you are getting because it's the same all across the fleet. But when you're having, remotely driven vehicles or some human operator guiding these vehicles, it's not always the same because we as individuals are different. And in this case, the representation in the vehicle is different. So these are factors that I consider part of the human factors limits. And now I'm coming to the end, which will be on the next slide. And that's summary, in which I'm trying to say that manual, remote, and autonomous driving are all complementary. They are part of one functional system that we can't really separate. We can't really have manual, remote, and autonomous driving really, as some discrete independent events, but they make all sense within the overall system. Amol, could you switch to the next slide, please? So they have one shared they are all, part of one shared system, and they have their own place. As I said, remote autonomous driving might be meaningful most of the time, 99% of the time, but during that 1%, half of that might be dedicated to remote driving because the vehicle needs some assistance, some help with dealing with some situation, and another half of that 1% might be fully manual driving because the vehicle needs to be moved, for example, to car wash, and the autonomous driving system is not really programmed like that. So there are these very limited, very rare events that might happen and need these sort of other ways of driving that are important. So to wrap it up, I try to say really that the place of remote driving within autonomous driving is quite important, quite crucial, and won't be really removed from it in the near future. And if we are thinking about having some meaningful, functional, safe, reliable system of autonomous vehicles, some fleet or something like that, then considering all these three functions as part of this system is a very good idea because it will prevent us from issues that will be hard to resolve just by having only one of these modes. Of course, we can try to have fully autonomous service, fully manual driven, fully remote driven, but in this case, each individual system will bring its disadvantages. So our goal is to combine advantages of each of them and have system that's superior to all other ones, which are based only on one of these driving modes. So that's all from me. I'm glad for your attention. I hope it was helpful to you, and I apologize for the initial technical issues that we encountered. But thank you so much. And if you have any questions, please feel free to ask either through a microphone or text message, and I will try to answer them. Thank you so much. Yeah, I can see Prem J is trying to...
If anyone having doubt, they can ask.
Huh?
If anyone having doubts, they can ask.
Yeah, Ravi, you can ask.
Hear me?
Hmm?
Okay, so you were talking about like the last example was car wash. You never knew we never know, for example, how long it has been. The car has been washed and stuff. So I have like 2-3 questions, if that's okay.
Yeah, totally.
Okay. So when we were talking about like autonomous vehicles, I have like 3 points on the end of the autonomous, like the control system point of view, like the safety, ethical, and privacy concerns, of the vehicles. And on the side of like the drivers, we have a problem with how do we train people to adapt to this current technology, for example. Do we have a license, and let's say, do we have to train people regarding like how to control these vehicles as well? Because now we're making our vehicles more human-like. We have all senses, visual perception, sound sensors, and everything. So I'm just thinking like how do we, address these questions?
Yeah, thank you. That's actually a very good question. And in terms of training, I think we can distinguish between several categories. We can have training for these operators. Of course, if someone is a remote operator, then they have to go through some training. They need to learn how to use this interface. They need to know how the vehicle reacts to the commands and how all these things operate. So yes, definitely there is necessary training, and some of these companies have already come up with some training procedures, some guidance manuals how to do these things. In terms of training for autonomous driving, using autonomous vehicles, you usually have to train safety operators. These are people who oversee this vehicle, usually during some preparatory phase when they test these vehicles and they want to make sure that they can handle situations and they are safe. Once they feel, okay, the vehicle handled everything that it encountered so far, we can remove these safety operators and the vehicle can drive itself. Yes, these safety operators need to go through some training. If you're talking about users of autonomous vehicles, they most likely don't need any training because it's basically like hiring a taxi cab. You just, or Uber, you use your phone, it comes, you sit inside, and that's it. Also, what's interesting in terms of training, and I feel like you mentioned it a little bit, is when we have not autonomous driving, but advanced driver assistance systems, like cruise control, lane keeping assist, all these functions which are currently available in modern cars. But they don't fully automate the vehicle. They only automate some of its functions. Like they for example, keep the speed for you, keep the distance from the vehicle in front of you. They keep the vehicle within its lane, or they check for you your blind spot. So all these functionalities are in the vehicle, but actually the driver is not really prepared for them in sense of going through some formal training. It's usually like you buy a car, it has these functions. If you want, you can read a manual to that, but let's be honest, many people don't really read manuals, so they might not even know how to fully control these things, these devices, and they just experiment with them while driving. So there are some activities or initiatives to prepare some sort of formal training for these advanced driver assistance systems. Some car manufacturers already offer something like this, but it's fully voluntary and people might not really be willing to go through these trainings. So what we see right now in terms of road safety is that there is this sort of gap between accessibility of automated functions in current cars and actually knowing how to use them. So that's something that I see currently, or the industry sees as something that might be problematic in the near future or even currently, because people are not trained for these things. So I hope I answered your question.
Sure, thanks.
Yeah, feel free to ask any other question. Can Tesla cars be called as autonomous cars? No, they're not autonomous cars. They are cars with advanced driver assistance systems. That's the systems that I talked about. Tesla cars, at least in the form of autopilot, that's basically so-called level 2 automated vehicle based on SAE levels of automation, which means usually they have the adaptive cruise control, so the vehicle can manage by itself the speed and the distance from the leading vehicle, the vehicle that's in front of you, and it can manage the lane keeping. So it can stay in the lane. Some more advanced functionalities might be like changing lanes for you, or guiding you on when it's safe to change a lane. But still, this is part of these advanced driver systems, so it's not really autonomous. There are some, probably the full self-driving beta version, the functionality of Tesla cars might be called level 4. In this case, it would be autonomous driving, but it's so limited in terms of its operational design domain because it requires so many interventions that it's really like very limited or very immature version of autonomy. There is another question. How does V2X communication technology contribute to functionality and safety of autonomous driving systems? That's a great question. And, you know, V2X communication was something that over the last few years has been part of very heated discussions. But the truth is that first you need fully functional autonomous driving system that doesn't really rely on these external helps. Because if you have safety critical system that needs for safe operation something that, you know, is not very reliable or fully accessible, then it can cause a big problem. So V2X communication is like nice to have functionality. This means, you know, it can help you to achieve even, you know, higher comfort of your driving, but it shouldn't be part of, you know, some fundamental driving part or functionality, because you can't really fully rely on some you know, wireless communication with some infrastructure or other vehicles and so on. So in this case, yeah, it can increase the comfort of your driving. For example, when these vehicles can communicate with each other, they can somehow optimize, you know, the driving experience. So the vehicle doesn't have to brake that often. It doesn't have to, you know, merging on highways might be easier and so on. So communication in between vehicles might be helpful, but it's additional to, you know, having fully functional autonomous driving, or, you know, exchanging information with some infrastructure. For example, informing you about that there is some ice on the road or there is some, you know, crash ahead is also useful, but the vehicle shouldn't really rely fully on that. It's like some additional information that it's good to consider, but shouldn't be really the vital part of driving. So that's my way of looking at V2X communication.
Anyone can ask a doubt from speaker.
What are the challenges related with autonomous cars? There are many of them. I would say there are at least 3 main categories. And the first category are, you know, technological challenges. The technology itself needs to be developed enough in order to, you know, function safely and reliably. We have different. There are many, you know, different companies working on this. They have different. They manage to conquer this task, you know, in different levels. Some of them are better, some of them are not as good, but they are still trying to work on that. You have issues within this group, like you know, detection, which relies on sensors. You have prediction. You know, the vehicle needs to, you know, predict what other road users will do, which is challenging. And the driving itself might be, you know, also challenging part. So this is like technological issues. Then we have, let's say, legislative or regulatory issues, which is also another quite a big challenge for autonomous vehicles, because currently in many countries, the regulation, the law doesn't really allow for autonomous vehicles. So this is something that needs to be changed, or there need to be some new policy or some temporary, you know, permit or something like this. So it means that what's stopping these autonomous vehicles from being, you know, used is that there is no really some regulatory framework for them. And this usually when there is some law that needs to be changed, it takes a lot of time. It's not necessarily wrong, because, you know, you want to make sure that the general public is safe and they are getting some meaningful service. So these policymakers usually try to make sure that if they approve something, then it will have more benefits than disadvantages. So this is regulatory issues. And the last challenge, I would say, is public opinion challenge. In this case, it means that people have to feel that they want this sort of service. There is something that is benefiting them. So public opinion in many countries currently is one of the biggest challenges, because you can hear from many people like, I like driving, I like my car, I don't want to switch to autonomous driving, I feel like it's taking away my freedom, and so on. So all these things are really playing a role, and the autonomous driving industry has to manage all of them. So these are challenges that I see as something that autonomous driving really needs to resolve or address in order to be fully successful. So there's another question. What are the I think I saw some question about the technologies used for autonomous driving. Yeah, I can also address that. Usually when we talk about autonomous driving, autonomous cars, we talk about two subsystems. One is sensory system, which can be basically talked about as some human senses like eyes, ears, and so on. And there we have some like a computational side, which can be seen as human brain for processing all these sensory inputs. And in terms of autonomous cars, autonomous vehicles, these sensors, there are many of them, and they are there because of redundancy and also for complementarity, because each sensor has advantages but also disadvantages. So usually most of these autonomous cars, they have a combination of several sensors. It's cameras, it can be regular cameras, but also it can be night vision cameras, it can be other spectrum cameras or hyperspectral cameras. They have lidars. In this case, these are like laser, radars that they emit laser light, and they're measuring like reflections of these laser rays coming back to the emitter. So they kind of scan the environment. They can allow you to create 3D model of the environment, and they're very precise. And then we have radars that they usually are used for distance detection, and they also work in different environments. So they can see through fog and so on. So that's advantage above cameras, which are limited by vision and so on. We have also other additional sensors like GNSS. So there is some connection with satellites, so they can help with positioning the vehicle. They have some inertial measurement units, so it also allows with localization and so on. So it's a combination of sensors that all work together, and they feed the computational unit, the onboard computer, which is processing all this information, and it's creating like a model of the environment, of the surroundings of the vehicle, is assessing and predicting the movement of other vehicles, other road users, pedestrians, and so on. And then it's issuing like commands on what the vehicle should do next and how to move in order to be safe in that environment. So these are like the main technologies which are part of autonomous vehicles. How are LiDAR advancements shaping the future of autonomous vehicle technology? LiDAR is definitely something that is increasing in popularity, and also because of that, the price is dropping down and is being more widely used. And in the beginning, LiDARs were considered like the important part of autonomous driving, but now we can see that many car makers are implementing LiDARs even into cars that are meant to be used for massive by masses. So it means we have also like this level 1, level 2 vehicles, which means they have just some advanced driver assistance systems like lane keeping, adaptive cruise control, but they also use LiDAR because of its benefit to safe driving. So yeah, LiDAR definitely will play more role, will be more important. We will see it more often because it's getting cheaper and manufacturing is in much bigger numbers. Where am I from? I'm from the Czech Republic, and now I am in the United States. What are some data sets used by engineers making autonomous vehicles? That's a very good question. And actually, these data sets, they can be, many of these AV developers, autonomous vehicle developers, they publish their data sets, and they allow engineers, everybody who's interested in this to work with them. For example, a company called Motional, they have their data set available. I think Waymo also published some data set, and what it includes is usually they have synchronized video footage, they have LiDAR footage, they have the video footage might be pre-processed, so you have some object classification there. You might get some GNSS information and probably some other items as well. But I think the video LiDAR are probably the most common pieces of these data sets. Can we think about hybrid in autonomous and manual? Yes, totally. Because when we talk about autonomous vehicles, we also, especially, there are these level of automation issued by Society of Automotive Engineers, and they talk about different capabilities of vehicles. And currently we have autonomous vehicles at the level 4, which means these vehicles are able to operate by themselves within some operational design domain, within some envelope, within some framework, which is defined by road conditions, road environment, weather conditions, and so on. So, when the vehicle is within this operational design domain, it works autonomously. But it might encounter a situation when it goes, outside of this ODD, and then it needs, some help. It can be the remote intervention or manual driving. So, yeah, totally. There can be a combination or hybrid between autonomous and manual. And I think it was also something that I tried to address in my talk, that it's not either autonomous or either manual or either remote. It's ideally a mix of all these three, and that's what makes the system fully functional and fully safe and reliable. How the privacy of passengers can be maintained in autonomous driven vehicles? I would say it's not just passengers; it can be also just people around, or basically anything, anywhere, anywhere where these autonomous driving systems are working, because there's so many cameras, they collect so much data that the privacy becomes quite an important issue. When we talk about just the passengers in these autonomous vehicles, based on the information and policies that are published by operators of these robotaxi fleets, they admit that they have a camera inside of the vehicle, which allows them to see the interior, but at least they say that they don't record the interior, and they're not watching the camera all the time. They only connect to this camera when, for example, the rider asks the rider support something, or when the vehicle detects something unusual, and so on. So it seems like these companies are trying to provide privacy to passengers, and the only thing we can probably do is to trust them. In terms of privacy of people around the vehicles, that might be more challenging. Usually, what we can see is that these companies try to work with some sort of blurring. For example, if they have some facial recognition, they might automatically blur faces. So if somebody is reviewing the video feed from these vehicles, it might already be with these blurred faces, so they can't really see who exactly the person is. This might be also kind of compliant with, like, European GDPR. So if something like this is operated in Europe, it might even be, required. So there are plenty of activities in order to, secure privacy for people. But also, of course, it differs from country to country. But I think this will be definitely something that, with the expansion of these services, it will be even more important and will be even more enforced. So yeah, that's definitely a great question and very important topic. Oh, thank you so much for these great questions, and feel free to ask some more if you have still some time.
Thank you, sir.
What will happen if a self-driving car loses power? Usually it stops. That's what happens. I'm not really aware of a situation when, the battery will go flat. In an autonomous vehicle, usually when there is some indication that this might happen, the vehicle usually does something that's called minimal risk maneuver. So it will try to basically get to, on the side of the road, or will try to get to the nearest parking lot, and so on. So there are these precautions that are being implemented in these vehicles to prevent something like this from happening. Of course, you can't really, guarantee that for 100%, but I would say naturally, if there is some power loss, then the vehicle would just stop. What about the lithium batteries disposed after its life? That's another huge question and a huge topic. This doesn't really necessarily relate just to autonomous vehicles, even though it seems like most of the autonomous vehicles in the future will be electric. But this relates to the electric vehicles ecosystem in general. And yeah, this is something that probably will be studied even more. Currently, as far as I know, all batteries from vehicles are tried to, people and companies try to use them for some secondary tasks. For example, like some storages at home, energy storages, where you can, if you have solar panels on your roof and you need to, or want to save that energy because you don't have immediate use for that, you can store it in this battery and use it when, for example, at night when there is no sun and you need to kind of use that for your purposes. Yeah, I think that the research still is ongoing on this, and there might be probably some other ways how to recycle lithium batteries or use them for some other purposes. But yeah, this is definitely an important issue because it's quite a rare element, and yeah, if it's really important because otherwise we might run out of these things. So yeah. Yeah, it seems like we are probably done. And yeah, thank you so much once again for your attention, for your great questions. And yeah, I'm looking forward to hearing from you or seeing you again next time. Thank you. Have a great rest of your day, and yeah, see you again soon.
Thank you, sir.
Thank you. Bye-bye.
Hello, learners. Thanks for attending this session. I hope you all liked the webinar and looking the exposure to enhance your learning and skills in the same domain. Okay, so here I would like to introduce ISI India products, which will help you enhance your skills. So come take a look of a small video about ISIE India products and their courses that helps to enhance learning and gives the opportunities for the placement. Okay, have a look, please, learners.
Hello, engineers. Do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISI India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV CAD and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling, and upskilling, at engineering institutes across India, we are setting up a state of art facility, Center of Excellence for e mobility research and skill based education, which is equipped with research and project based learning oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation, and product design and development. It is a combination of 6 labs, including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab, and renewable energy lab. Each lab is consist of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, two-wheeler, three-wheeler, four-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off-grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions, and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Okay, thanks learners for watching this video. Hope you guys have understood the products. So any of you wants to enroll in our courses or interested in the courses, so kindly send us the inquiry through a QR code that displayed on your screen. So please hear carefully those who are interested to know about EV courses or want to join the courses, only those have to see the QR code that are displayed in the screen.
Anyone who wants to inquire about the courses in EV technology, they can scan this QR code and fill this form.